Good evening, everyone, and welcome to Sky Observers Hangout. We're so glad to have you here today. My name is Michelle, and I'm the Director of Public Observing at the Adler Planetarium in Chicago. And I have a friend joining me, as always. Hello, friend.
Hello, it's me. I am Adriana. I am the astronomy educator at the Adler. We've also got some friends joining us behind the scenes this evening. Our YouTube chat moderator tonight is Sarah. Hi, Sarah. And also, if you see, if you see the Adler's name highlighted in yellow, that's her helping us with your questions and comments. And we've also got our astronomer friend Geza here. You'll see the little blue wrench next to his name.
And Sky Observers Hangout, especially if this is your first time here, this is our place to gather together to nerd out about the sky. And our goal is to give you practical tips for information that you might find useful about a lot of things related to sky observing. If you want to just watch the show, that is totally fine. We would also love to see your questions and comments and observations in the chat. Feel free to interact with us and with each other.
Absolutely. We genuinely love hearing from you all. So, to get the show started, if you haven't already, tell us in the chat where you're tuning in from and let us know, have you ever seen the Northern Lights or auroras in general, wherever they come from?
Exactly. Now, while you do that, while the Adler's doors must remain closed for only a little while longer, we're doing our best to keep our virtual doors open by creating and sharing some out of this world content for all of you. If you wouldn't mind, please use the link that Sarah's going to put in the chat in just a bit to donate what you feel comfortable to contribute to our programming. Thank you so much, as always, for allowing us to keep sharing our universe with you.
And you can also help us get more visibility for our shows by hitting subscribe for the Adler Planetarium's YouTube channel. That's going to be right below this video. If you like us, you can also give us a thumbs up. We are also very pleased to mention that the Adler Planetarium will fully reopen to the public on Friday, March 4th, 2022. We
Woohoo!
cannot wait to see, yes. We cannot wait to see all of you again. Admission tickets will go on sale very soon, so keep an eye out on our social media channels and our website for more information about all of that exciting news. Now, let's see where you all are tuning in from and see if folks have seen auroras before. Hi, Karen. Got friends from Independence, Iowa. Very fun.
Our
From San
friend from
Antonio.
Independence, Iowa has joined us before. I seem to
Yeah,
recall either that or we have a fan base in Independence, Iowa. So that's cool.
maybe. Hello, Angela from Washington. Hi, Linda. So we've got some people saying, oh, from San Antonio, but I'll never see them down here. I understand. It's unfortunate, but we'd have to travel. Let's see. Saw the Northern Lights in Alberta, Canada. Oh, that's super exciting. Um,
A little later, I'm going to tell my little story about seeing them in the
absolutely.
vicinity of Alberta as well. So
Just barely saw them only once, very, very faintly from Wisconsin. A lot of people who haven't seen them yet, don't worry, no shame. I haven't. We will one day. We'll get there.
all of us, yes.
Utah, never seen them before. Hello. Well, thank you all for joining us. I know some of you have seen them, some of you haven't. But that's why we're here. We can talk about where and how you can go see them yourself.
Absolutely. So keep those comments and messages coming in the chat. We love, love, love hearing from all of you throughout the show. All right. Thank you all for joining us. And we are so glad you're here. Now let's get to it. Let's talk about the Northern Lights, also known as the Aurora.
Let's do it. So, to get the basics down, let's start with understanding what auroras are. Michelle's going to give us a photo in a moment. An aurora is a glowing sky light show that you can see at night. The phrase northern lights specifically refers to the auroras we can see in the northern hemisphere, closer to the North Pole. But the southern pole also gets auroras called the southern lights. But let's talk about what actually causes them. This glowing skylight is caused by energetic particles from the sun interacting with the Earth's magnetic field, and the process also involves gases in our atmosphere. That means that to understand auroras, we have to think both about what's happening on the sun and how that interacts with the Earth.
So our sun has a superheated atmosphere. made of solar material that's bound to the sun by gravity and magnetic fields. As rising heat and pressure push that material away from the sun, it reaches a point where gravity and magnetic fields are just too weak to contain all that. That boundary marks the end of the solar atmosphere and the beginning of the solar wind. The solar wind is composed of energetic charged particles like protons and electrons. The amount of solar wind isn't constant, it changes. Sometimes there's less, sometimes there's more. Sometimes the sun releases a huge cloud of energetic particles, and that is called a coronal mass ejection. And I'm going to switch here. There we go. All right. So when these charged particles sweep toward the Earth, and I'm going to play a quick little video right here so you can watch. So when those particles sweep toward the Earth, they are mostly deflected by our magnetic field, but some particles get trapped within the magnetic field. When a burst of solar activity impacts our magnetic field, the trapped particles can be redirected and accelerated toward the Earth's poles. Those particles interact with gases in the Earth's upper atmosphere, and this process releases energy in the form of light. That's the light we see as auroras, and that's why we see it closer to the poles. By the way, this little video clip is of a coronal mass ejection that basically overwhelmed the detectors of a couple spacecraft that took this. You can actually see sort of the radiation from that huge burst from about 10 years ago.
That's really cool.
Yeah.
All right. So why does the light that we see in auroras come in different colors? That's because of the different gases in the Earth's atmosphere and the different altitudes where the particle interactions are occurring. So nitrogen is responsible for blue and some red emissions. Oxygen is responsible for the green color and some red emissions as well. And there are lots of other colors that you can see too. There's blues, purples, pinks, yellows, and more.
However, you don't need the sun to be particularly active for auroras to be visible. Thanks to data from NASA's Themis Artemis spacecraft fleet, we now know more about how, even when there aren't any solar storms and when solar activity is really low, there can still be auroras on Earth. We're simplifying the explanation a little bit, but what it boils down to is that electrons high above Earth's poles are accelerated by Earth's magnetic field upward and outward into space. Along the way, these moving particles stir up ripples of energy in Earth's magnetic field, and these energy ripples cause electrons to get knocked off of other atoms out there. And these secondary electrons rain down on our poles and on our upper atmosphere, causing diffuse, hazy green auroras.
Very cool. So this process was only described in a science paper a couple of months ago. It's pretty cool that we're still learning about auroras on our home planet, Earth. Now let's take a look and see if you all have any aurora questions yet that you want to learn some answers to. I see a comment from Geza. To the eye, the green will dominate. Yes, but sometimes you'll get lucky, and a particularly magnificent display will show the other colors clearly. Very cool. I don't think I see any questions in the chat yet. Dan says, only saw them in my dreams. Me too. We've still got time.
We've got time. Yeah, we're heading toward a time period where you're going to get the chance to see them a little more often. So, or we're going to tell you how to.
And also, hello, Malia. Okay, let's continue.
We love saying hi to you guys. So it's just awesome that that we know that you're out there. It's so cool to know you are on the other end of the computer screen or phone screen. So it's a lot of fun to interact with you. Even if we can't see or hear you, we know you're there in the chat. So keep those questions coming.
Oh, we do have one. This is Malia. Hi again. I was wondering if the Northern Lights color is only and always green and blue, or can they come in different colors? Yes, they can come in different colors.
Yeah, they absolutely
Michelle can speak more to it.
But the color that you're going to see most often is green, and there's also it's also kind of interesting because the human eye may not allow you to see those colors very brightly. So that green one is going to be the one that is going to show up It'll be kind of a hazy gray green. They're going to show up so much more vibrantly in the pictures than they will to your eyes. We're going to talk more about that, but yeah, the green and the red are what you're going to see most often. Those others, they're there, but you might not see them. They might not show up except to maybe a camera. So again,
Yeah.
we'll talk a little bit more about that.
Yes. Ooh, we are getting some other questions here that we are just about to answer. So I'm going to move into it and we'll make sure that we get these questions answered in the process.
Yep.
All right.
Absolutely.
So we get asked a lot about when and where people should go to look for auroras. We've already got one of those questions in the chat. I see you. So you might want to plan a vacation around seeing auroras, or you're just curious if they'll be visible, where and when you're traveling. While no one can predict exactly where to go at exactly what time to see an aurora, especially more than a few days in advance, there are some tips that we can give you. Also, just a quick note, there are auroras in both the northern and the southern hemispheres, as we mentioned before. In this show, we're mostly just going to talk about the ones in the northern hemisphere. We're going to talk about the northern lights because that's where we are. In the southern hemisphere, you tend to see auroras more often in southern Australia, New Zealand, southern Chile and Argentina, and Antarctica.
Now, the northern lights happen all year long, but that doesn't mean they're easy to spot or necessarily visible all year long. You need to be the right place at the right time. So I'm going to share an image here, and here we go. There it is. The place to see an aurora most often is any destination in the quote unquote auroral zone, an area within about a 1,500-mile radius of the pole. So 1,500 miles from the North Pole means for us in North America, northern Canada, northern Alaska, central Alaska, but you can also find yourself seeing auroras in northern Scandinavia, Iceland, and far northern Russia. Now, the best time of year to see the northern lights is generally between September and March, and opposite months in the southern hemisphere. This is in fall and winter. Why not in spring and summer when it's warmest and you might actually want to be outside and out and about? The closer you are to the pole, the more daylight you experience, up to 24 hours a day north of the Arctic Circle or south of the Antarctic Circle. Now, while the aurora continues to happen even in the daytime, you won't see it due to the sunlight. The most aurora action usually happens between local times of 9 p.m. and 3 a.m., and around local midnight is a great time to go out and look. Now, if you decide to go to one of these far northern locales, you will probably want to base yourself in a destination with transportation options and guest experience infrastructure. And we're talking Fairbanks, Alaska, we're talking Yellowknife, Canada, Svalbard, Norway, and don't forget basically the entire island of Iceland. You may also want to investigate using an expert guide. Towns and cities in these areas will be pretty built up, but they may be based in remote areas with harsh climates and harsh local landscapes, and sometimes with large wildlife. And that wildlife may not actually want you to be there. So they don't want to see you in person. So a local guide is going to get you to the best place at the best time, and also help find you a spot that's safe to go to.
Yes. Geza pointed out fall is particularly wonderful because it hasn't gotten too cold yet. Good advice.
Good advice. And maybe by that time, a lot of the local mosquito population will have gone away by then. That's also something out in the middle of nowhere you have to worry about. So
yeah.
Go ahead.
So in addition, you want to make sure that you're getting away from city lights. Of course, a lot of these places that we mentioned are away from city lights, but light pollution will wash out dimmer phenomena, and auroras are often dim. Also, don't forget, light pollution can also be caused by the moon. So that's something to think about if you're going to plan a trip. A bright full or almost full moon in the sky fills the sky with light. So try to plan your travel for maybe a week on either side of the date of new moon. You can get the dates of new moon from lots and lots of different sites, including weather forecast sites and apps. And when you get out there, you'll have to give your eyes some time to adjust to the dark. As we've mentioned many times, it takes about 20 to 30 minutes to see your best at night for your eyes to get dark adjusted. So you'll have to wait a while before some of the dimmer parts of an aurora might be more visible to your eyes.
Now, speaking of the weather, check the forecasts and the local cloud trends from where you're going. In some locations, you may be more likely to get cloudy weather at certain times of year, and you generally can't see auroras through clouds. Just like our telescopes can't see through clouds, can't see through clouds to see those auroras either. Auroras happen at much higher altitudes than the clouds that you can see. These cloudy times may be different from one region to another, so be sure to ask local experts for their recommendations. They'll know the weeks and months to avoid. All right. Should we check to see if we have any questions that we possibly haven't answered yet?
Yes. So we got to a lot of them are about places to go see them, which we've touched on here.
By the way, related to that, Yellowknife, Canada is very well known. If you're going aurora hunting, that is a very popular place to go. It's where a lot of the if you're going to go with a tour group or something like that, they're generally going there. So just a thought for that as well.
Yeah. Karen asks, "Yikes, wildlife?"
Yes, sometimes big ones. Think moose. So I'll tell the story in a little bit of when I got to go to Canada to see the Northern Lights, but I'll tell this part of it here. We were literally out in the middle, like 2 hours away from a town, no cell service whatsoever. We had to, the person leading the group had to bring a satellite phone because we were that far out in the middle of nowhere, and we always had to have somebody watching for moose, because they would go one moose and bison, and I'm saying bison instead of bison because that's how they pronounce it in Canada. So we had to watch out for bison and moose wandering through the camp, and if you saw one, you had to alert everyone. So yeah, there can be some pretty big wildlife out in the middle of nowhere, especially in Canada.
Yikes.
Yeah, yeah.
All right. Should we talk a little bit more about what to expect to see?
Absolutely. I get to share more pretty pictures. Let's get
Excellent.
those up. So go ahead.
So, auroras have been called simultaneously the most amazing and the most disappointing sky phenomenon. So, we've all seen pictures like this one of auroras, very colorful. We've got reds and greens and blues and purples. Do auroras look to your eyes exactly as they appear to look in pictures? The answer mostly is no. So there are several reasons why. Your eyes aren't all that sensitive to color when you're out at night, so that might be a problem when you're out watching a nighttime phenomenon like this one that has color as an important component. It means that colors that you see at night tend to be washed out. When you do see color, the human eye is more sensitive to some colors, like green, than to other colors like red, so the dimmer red auroras may show up better to a camera instead of to your eyes. Also, a lot of the camera images that you see were likely also taken with the camera shutter left open for a while, letting in more light over a long period of time, and that makes the aurora look brighter in the picture than it appeared to the eye. Some of the aurora colors, like blue and purple, are just usually really dim, and so you might not see them at all. And let's face it, a bunch of those images that you may have seen are possibly highly processed afterwards to bring out certain colors or features, as people tend to do with astrophotography. So the bottom line is, don't expect to see a rainbow of colors in the sky, but that doesn't mean that it's not cool, right, Michelle?
Correct. And I realized we just probably took the rug out of everyone's feet and went, "Oh my God, this is going to be terrible." But no, this sounds frustrating, but it's really not. What will you see? You will see structure. You will see movement. You will see shape. And this is all really interesting stuff to see in the sky. The shape of the aurora depends on where in Earth's magnetic field the electrons come from and the process that caused the electrons to rain down into the atmosphere. Dramatically different aurora shapes can be seen in a single night. You may see what looks like curtains or spokes or pinwheels or spirals. You may see arcs or bands in certain parts of the sky. Auroras may appear to not move at all, or they'll move slowly from one part of the sky to another, or they may wildly pulsate. You may see the aurora away on the horizon, or it might suddenly blast into view above your head, covering most of the sky. You may see a light green color, or you might see red if the solar storm is particularly energetic. No two auroras will ever look the same, and two people in two different places getting two different perspectives on the same aurora may see fairly different things. I hope that got everybody excited. All right. So maybe you're in Chicago, or you're in the Chicago area, and maybe you aren't planning to travel someplace far to the north. Can we see our auroras in our area, or our friends out in Utah, or Colorado, or even Texas, or California, or Washington, or out east? Can any of us see auroras in our area? The answer is yes, just not as often. First, we are farther from the North Pole than the auroral zone. All right, that makes sense. The Aurora Zone is about 1,500 miles from the North Pole, as we said, and Chicago is almost 3,000 miles from the North Pole. Makes sense that we won't see it all that often. We're a lot farther south than where they're typically visible. We need stronger levels of solar activity to occur so that the aurora is seen farther to the south. Those stronger levels of solar activity don't happen nearly as often. And if you wanted to get a better chance at seeing auroras in the lower 48 United States, try far northern Minnesota, far northern Wisconsin, the upper peninsula of Michigan, or basically any of the far northern tier of states in the continental, in the lower 48. Maine is also another great place to go.
Yeah. Um, I am gonna. Oh, okay. Gaze has got it. Sorry.
Oh,
So,
no problem.
Michelle,
It's a fun part about questions popping up. We got folks answering, so it's great. Okay, go ahead. Sorry.
yeah. So, Michelle, you've seen a couple of auroras, right? Can you tell us
Yes.
about that?
Yes. So the first one that I saw was about 20 years ago. I live in the far western suburbs of Chicago. At the time, we were living in St. Charles, and for whatever reason, and this occurrence did not normally happen. It was either my husband or I would take the garbage out to the dumpster out in the parking lot. Well, that night we had a few bags of trash to take out, so both of us went. We took the garbage out. I looked up like I normally do, and I went, oh, there's a lot of light pollution in the sky tonight. And then I looked up again, and then I realized what I was looking at. I was looking at a bright red aurora. It was visible in our entire area, over the entire Chicagoland area, even in light polluted St. Charles, Illinois. I was jumping up and down like a crazy person in the parking lot, stayed out there for like 40 minutes watching this. Everyone who was wandering by, I was pointing it out, and I'm not sure if they cared, but I didn't care. So yeah, so yes, so I saw so that particular aurora in the parking lot of the apartment complex where we were living at the time. So there was
And I
that
wish it was
one.
that exciting when I take out the trash.
See, what the moral of the story is, whenever you're outside and it's dark out, look
Look up.
up. You never know what you're going to see. And so the other time that I saw it was 5, 6 years ago. I was invited to um, the the Dark Sky Festival um, in Canada. It's put on by one of the local astronomy clubs in the Fort Smith, Canada area. And so that's where we went out to Wood Bison National Park, and we were out in the middle of nowhere. And so I was looking forward to seeing what the dark sky was like out in the middle of nowhere. Couldn't tell you what the dark sky was like out in the middle of nowhere because the aurora was so bright that I could not see the stars very well. Couldn't tell you how dark it got because the aurora was so amazingly bright. Now, this picture is of me, and I'm standing. They constructed this wooden platform for people to either walk or roll up onto, and it had leaned back. Um, seats so you could like literally just lean back and look up at the sky for as long as you wanted. It was also a great place to run to if a bison or a moose was wandering through, because we figured they probably wouldn't wander up the wooden ramp. Anyway, you can see the tents. They had tents, cabins, and all sorts of stuff there. Well, this picture was taken by a professional Aurora photographer, one of the best in the world, and he left the shutter open on his camera, and at one point he took a little flashlight and he kind of painted me. I'm wearing a glow stick around my neck. It's what you see in the picture. And he kind of painted me with the flashlight so I could show up in the picture as well. I think he left the shutter open for 30 seconds, a minute, something like that. What I could see was the color, was the shape, the structure, the movement, all that stuff, pinwheels, spirals, you name it. I saw it. The green color was kind of a hazy green, kind of a gray green. It wasn't a vibrant color, but it was bright. The aurora itself was bright. It's just that the green wasn't bright. So, oh my God, if you all get a chance to go see this, please go. By the way, I'm noticing you can see some purple in the picture. Could not see any purple whatsoever. So that was not visible to my eye, but just an amazing, amazing spectacle. Really cool. Just a direct connection between the sun and the earth. Just astonishing.
Very cool. We've got a couple questions here, Michelle. Can I go ahead and
Yeah,
ask those?
love questions.
Um, excellent. I'm seeing, are aurorae brighter for the astronauts on the ISS?
Oh, great question. I would say, here's the funny thing. Sometimes the aurora is happening above the International Space Station. They can happen anywhere from maybe 60, 80 miles and up uh, to several hundred miles up, even a little higher than the International Space Station. Um, but you got to remember the space station um, is traveling through 45 minutes of daylight, 45 minutes of darkness. It orbits Earth once every 90 minutes. So once they get into darkness, and once they're on the side of the earth not facing the sun, and maybe there's an aurora happening, you still have to get your eyes adjusted to the dark. You still have to give yourself about 20 minutes or so. So you've already lost about half the time period for your eyes to actually see a phenomenon like that. And if they're inside a brightly lit space station, it's going to make it a little harder. So they got to turn the lights off and everything in order to see. So not necessarily brighter to the human eye. Cameras can get a great view. They've gotten views of pretty much close to the entire auroral oval at once, or close to it, from up there. So that's a view that we don't get to see. We see part of an aurora. They get to see a huge chunk of it, but not
Very cool.
necessarily brighter.
Yeah. Okay. And then somebody asks, have they ever seen a display in Miami?
Yes, there have been auroras that have been seen as far south as Hawaii, pretty close, getting down close to the equator. So Hawaii is what, about 20-ish degrees north latitude. Miami's higher than that. Yes, they have seen them in Miami, just not that often, but it has happened.
Not while I was down there,
Not while
unfortunately.
you were down there, unfortunately. So you have a better chance here.
Yeah. All right. I think that's all of the questions we see. So let's carry on here.
All right.
So I know we'd love to be able to tell you exactly where to go and exactly what time of year you can see auroras. You can roughly connect how well we can predict auroras now to how well we could predict the weather 30 to 40 years ago. Simply put, we're not that great at it. We're not great yet at predicting solar activity, and we're not great yet at predicting what will result from a particular blast of solar activity that will interact with our magnetic field. So we still have a lot to learn.
We do. But there are two resources that we want to direct you to. for getting more information about where and when auroras might be seen. Because you're thinking to yourself, I want to go see one. They've convinced me. So what can we do to go see them? So give me a second. I'm going to share a portion of my screen. I just need to move a couple things here on my screen before I do that. So there we go. And I'm going to take you to the first one, which is spaceweather.com. Now, this website is updated every single day, and it gives you the latest outlook for the possibility of seeing auroras or what the sun is doing. Here, there's a cool video that they posted about a coronal mass ejection, a solar blast that wasn't pointed in our direction; it was pointed in the other direction in our solar system. It'll show you today's image of the sun. But what they have, if you keep scrolling down, they'll have the current forecast for an aurora. Let me click the USA one and give me a second. We'll see. Oh, that is the one that's there. There we go. So this is an aurora forecast for, please look up in the upper right hand corner, 60 minutes in the future. Not that far in the future, but this is a probability map. And so that means the brighter the color on the probability map, the more likely you are to see an aurora in the next hour. So notice it's kind of dim on this side, but brighter on this side. If you're underneath this oval here, it means you have maybe something close to a 50% chance of seeing an aurora in the next hour. So that's that particular aurora forecast map. All right, so then, and we've got another resource. I'm going to go back here. Um, so again, keep checking this when they have information about the possibility of seeing an aurora. This is a good website to go to. And the other one is from the University of Alaska at Fairbanks. And so I'm just checking to make sure that this is showing up on the on the live stream. Yep, it sure is. Good. And so there we go. So when it shows up on the screen, you'll probably see this map right here. And notice this is for today, but maybe you're not in Alaska. You want to scroll down. There's a map here. Click where it says North America, if that's where you are. And it will show you the latest map. So again, this is a probability map. This is for later on tonight. And notice where the aurora oval is. So again, where it's darker, where this band is, that's where you have a chance at seeing an aurora somewhere straight up above your head at some time during the night. Notice it says here low activity, and this number right here says KP index. What that means is how active is the Earth's magnetic field right now? And the closer that number is to zero, the less chance we have of actually seeing anything. But as that number gets higher and higher, that's when you might have a better chance. Now, there is also a green line on this map. That means if you're inside the green line, but close to it, north of the green line, but close to it, look on the horizon to potentially see an aurora. So this is from horizon view and closer to this oval. That means it might be farther and farther up on the sky. Now let's go forward in time. I wanted to point this out because I was kind of clicking through this earlier and I noticed, so this map does change from day to day. And ooh, notice that January 15th, January 16th. One one thing, it says here high activity. Notice where the green line is. The green line is down slightly south of the Chicago area. So around the time period of January 15th, 16th, 17th, somewhere in there, we might have a chance, low chance, of seeing an aurora maybe on the horizon in the Chicago area. Just remember, these forecasts change daily. So just because we're saying, hey, go out on the 15th or so and you might see something, doesn't mean that actually will come to pass. So anyway, but so if you go forward on the 17th, up, look, the green line is now farther north than the Chicago area. But it's a great tool to go to. Um, And notice also where it says time zone here. This map is given in universal time. Check to see what date that is in your time. Universal time, it might be January 11th, but in central time, it might be January 10th. So that might affect your time just a little bit. So, or the date that you go out. So just keep an eye on all that. They also explain all that. But hey, by the way, they have an Aurora camera.
Oh,
And
cool.
of course, there's no Aurora going on right now.
Would have been too easy.
Darn it. Oh, well. I'm going to guess that's the moon. But they do have a live aurora or live upward facing camera. So you might get a chance to see an aurora via their camera. So that's a cool thing that I just sometimes stare at every now and then.
Very neat. All right, we've got a couple more questions. I think Geza took one of them. This is not about the aurora, but do you do a zoom on stargazing? I bought a telescope, but have never used it yet. Cool, congratulations. On your new telescope, did find a YouTube video on how to use it. So we have a bunch of Sky Observers Hangout episodes on YouTube in our backlog about observing different types of sky phenomena. If there are specific questions that you have about your telescope, or about how to use telescopes in general, our next episode is going to be an Ask Us Anything episode. So we can talk a little bit more about beginner telescope use. We probably will not have enough direct information about the specific telescope that you're using, unless it's the same as one of our telescopes. But that doesn't mean that we can't help with other types of questions about what in the sky you might be able to find with your telescope, stuff like that.
Exactly.
So
We're going to give you,
tune
we're
in next
planning,
time.
yeah, a lot of people have that question. People want to know, where can I take my telescope, or what can I look at, or what's up this time of year? We're planning on talking about related topics like that. So if you want to join us for our next show, or if you want to watch the video afterwards, then yeah, we'll try to answer as many of those as we can. So we're going to collect your Ask Us Anything sky observing questions between now and then. So hopefully
Yes,
you can join us for
please.
that one. Yeah, we'll give you the place
Yes.
to go to send us your questions at the end of the show.
Yes. Also, Bob asks, could you share the space weather Aurora link that had the green blob showing current conditions? I think
Yes.
we did a little
Yes.
further up in the chat. That was the University of Alaska's Aurora forecast, right, Michelle? Was that it?
That may
Or
have
was it
been
the
the
other one?
spaceweather.com. So I will
Okay.
put that in the chat in just a second.
Perfect.
So there we go. So I just put that one in. And then the other one, oh, it did Sarah put the Fairbanks?
Yeah, Sarah put both links in the chat. So they're up there if you scroll up just a little bit too. Michelle's got the spaceweather.com link there.
Yep, I'll put the other one in there just in case the chat isn't showing up for someone who might have joined us late. So there you
All
go.
right, yeah. Great. So now let's get into a tiny bit of history here about auroras. We know now that auroras are caused by interactions with the solar wind, but this wasn't always well understood. For a long while, it was unclear what caused auroras. So explanations in the 18th century for what could cause auroras included magnetic phenomena, sulfur, vapors coming from the earth, and ignited air. All kinds of stuff. So in 1733, Jean-Jacques Dortu de Meran, if you speak French, I'm so sorry for what I've done to your language. But he was a
You did
French astronomer.
way better than I would have done. So good job. Anyway, go ahead.
We tried. But he was a French astronomer. He proposed that auroras were caused by zodiacal light particles falling into the Earth's atmosphere in a book called Physical and Historical Treaty of the Aurora Borealis. That's the title page that you can see there. And you can see his name spelled out just in case I said it wrong. So in that book, we can see some diagrams and drawings that were meant to represent auroras in the sky. I did notice and was excited to notice that in these images, we do see different shapes of auroras, like Michelle mentioned earlier.
Now, could you please say his name again, because I'm supposed to say it and I need you to say it because you've practiced?
I haven't. Jean-Jacques Dortus de Meran.
All right.
De Meran? Close
Demarian.
enough, everybody.
Demarian. Close enough, whatever it is. And I apologize to him and his descendants for absolutely butchering his name. I apologize. But his explanation in this book for the cause of auroras was the most widely accepted one in the 18th century after the book's publication. While we know more about auroras now, they were a mystery for quite some time. But a natural part of science is hypothesizing and testing to explain phenomena we don't understand and adapting our understanding when we get more information. It is so fun to look at the scientists like Demarian who were part of that history. And again, is this a book in the Adler Planetarium's collection, Adriana? Is that
Yes,
one
it
of
is. I'm
ours?
sorry, I should have mentioned that more clearly. But yes, that is one of ours.
That's cool. So we just have fun stuff in our collection, that's for sure. So
Absolutely. All right. And last but certainly not least, I was excited to share a little bit more tonight about auroras and art. So let's get into that. We want to share one more special thing. For many of us, our first experience of the Northern Lights or auroras is through photography and video. I myself, like I said, still haven't seen this phenomenon in person yet, though I hope to one day. But I've been grateful to experience it through the camera lens of other folks who work to capture these images.
So, because of that, we wanted to spend some time sharing about an astronomer, multimedia artist, and science communicator extraordinaire who captures images and video of the Northern Lights and uses those images to inspire audiences and communicate science. His name is Dr. Jose Francisco Salgado, and I believe this is him in this picture
It
right
is.
here. So, in a moment, we're going to show you a very short clip of a video from The Legend of the Northern Lights, which is a project that Dr. Salgado directed, photographed, and produced as part of his nonprofit KV265. KV265's mission is to communicate science through art. Now, this mission is executed um, through projects like Science and Symphony. Oh, there he is. It's been so long since I've seen him in person. It's so great to see his pictures. The mission is executed through projects like Science and Symphony, where videos featuring visuals of Earth and the cosmos are produced to be played in perfect sync with music played by a live orchestra. And so there is a picture of the Legend of the Northern Lights with the orchestra right there. So these presentations often come with a science lecture as well, so guests can learn more about the stunning images they got to see.
Awesome. So I got the pleasure of talking with Dr. Salgado to learn a little more about these projects. He shared that the motivation behind this work is that science can lead you into art and art can lead you into science. So Dr. Salgado's motivation to photograph the Northern Lights and make a film about them led him to make 2 more productions about the phenomenon and study the Northern Lights more formally. This also inspired him to lead actual tours to take people to see the Northern Lights themselves in Yellowknife in Canada. On these tours, he shows guests the auroras and offers a public talk about the physics behind them. He also teaches photography enthusiasts how to photograph them, which is neat. Dr. Salgado hopes to continue tours as early as March of this year. I love, fingers crossed, yeah. First of all, this image is just so beautiful. It's really cool to see them move. But I love that all of this was born out of his own fascination with and desire to capture the beauty of the Northern Lights. I also love that guests to science and symphony events or these tours may initially be inspired through the beauty of the art to learn more about the science, or on the other hand, they may be inspired by interest in the science but leave with a new appreciation of art and of photography, which after seeing this, who wouldn't? Um, Art and science are both born out of curiosity and observation of the world around us and can both be sources of deep inspiration and study of that world. So, work that shares both the natural beauty of the cosmos and connects us more deeply to the science, like Dr. Salgado's, reminds us of that. If you want to learn more, I know, right? If you want to learn more about his various projects, sharing both art and science, Sarah will be linking to his website in the chat.
Yep.
So go check it out.
That again is Dr. Jose Francisco Salgado.
That video is just so cool.
He's just the best. So, yep, there's his website in the chat right there. So, any other questions before we sign off for tonight? Oh, by the
Yes,
way,
friends.
I saw one in the chat. I know Bob Kapla was asking how I got to that 1 hour in the future image. So when you go on spaceweather.com, scroll down. It's on the left-hand side, most of the way down on the screen. So then I clicked on it. I just clicked on the image that was on the screen, and it popped up that Aurora forecast for an hour in the future. So it was via spaceweather.com.
Yes. Excellent. And I think Geza might be responding to a last question.
Yep, which
But I
is
don't see any other questions.
right. So I think that has to do with all the really nasty things that can happen with solar storms as well. So the Aurora is the beautiful one. The other things are not quite so great. But anyway, all right. Have we done it?
I,
Are we good? Shall
I
we wrap
think
this up for tonight?
I think we are good on questions. Yeah.
All right, friends. Before you go and before we go, we have a special request for our next episode. Our next episode is on February 7th, 2022. It's a Monday night, as usual. And it's a Sky Observing Ask Us Anything episode. This means anything you've wanted to know about the sky, telescopes, binoculars, or observing is on the table. To get started with questions, please click the link that Sarah is going to share in the chat or click the link in our description and submit your sky observing questions. No question is too big or too small, and we hope to see you there on February 7th. By the way, special guest Dr. Geza Juke will be on camera with us that night for once. You'll get to see
Woo!
him on the Zoom. So he'll be there answering your questions with us live in the chat. And we're just going to get through as many of them as we possibly can until you can't stand us anymore. Anyway,
We're looking forward to it. Really excited to get to hang out with Geza. All right. So, as a reminder, the Adler Planetarium will fully reopen to the public on Friday, March 4th, 2022, and we hope to see you there. Start making your plans to join us at the Adler, and if you happen to run into either one of us at our in person programs, feel free to come say hi.
We would love to hear about it anytime you are out there connecting with the sky. Wait for the ending slide on our broadcast for the Adler Planetarium social media feeds. And if you would love to tell us what you've seen, what you've been seeing, what you want to go see, just use the hashtag lookup, all one word, hashtag lookup, and let us know what you are seeing in your sky.
Yes, thank you so much for joining us and supporting our programming. We love sharing this time with you. And as always, we'd love to get some feedback from you. So Sarah's going to link a feedback survey in the chat. It'll only take a short time to fill out. And if you filled it out before, don't worry, please do so again so we can keep track of improvements or anything else you want to tell us. It'll help make our shows even better, and you can send us suggestions for future show topics. So you can find that feedback survey link in tonight's program description if the chat closes before you get to click the link. But the link will be in the chat.
Yep. And do not forget to subscribe to our channel if you are not already subscribed. Thank you for joining us, everyone. Please keep looking up. We will see you at the Adler Planetarium very soon, Friday, March 4th, and beyond. And we can't wait to see your faces in person. And just as Adriana just said, please tell us if you come up to us, you see one of us, tell us you're a Sky Observers Hangout watcher, and because we would love to give you a special thanks. So thank you, everyone. We will see you soon. Good night.
Good night, everyone.